This is for Year 12 methods. It comes out of Chapter 11, 11I question number 6. Using the same set of axes, sketch these two curves. For this particular domain, calculate the smaller of the two areas enclosed by the curves. Okay, so this one has a period of 2 pi, therefore I'm going to be drawing half a period. And this one has a period of 2 pi on 2, therefore pi. So if I was to consider the two curves, this has a period of 2 pi, so for pi on 2, it's going to be up there at 1, so it's going to look like this, and it would normally then continue up for 2 pi. And the second one has a period of pi, so it's going to have one complete revolution. So at pi on 4, it's going to be up here at 1, and it's going to be down there at -1. So we end up with that curve. I'm interested in the smaller of the two areas trapped between the curves, so I'm interested in this one here, which means I need to find the intersection point. So, where does the sine of x equal the sine of 2x? I can use the double angle formula here. That's going to be 2 sine of x cos of x equals the sine of x. Move the sine of x over, 0 equals 2 sine of x cos of x minus the sine of x, and I've got the sine of x as a common factor that can come out. 2 cos of x minus 1. Using the null factor law, the sine of x equals 0, therefore x equals 0 or pi, and that gives me that answer where they're touching, and that answer where they're touching. Or 2 cos of x minus 1 equals 0, which means the cos of x equals positive a half, which means x equals pi on 3. And that gives me this answer here at pi on 3. So this region, which is this area, which is the area of the smaller, is going to equal the integral from 0 to pi on 3. Top curve is going to be sine of 2x minus bottom curve, which is sine of x dx. And that's going to equal, okay, the sine in the integral of sine is negative cos, and a is 2, so I need negative a half cos of x. And the integral of sine is negative cos, so the integral of negative sine is positive cos of x. It's going to be negative a half cos of 2 pi on 3 plus cos of pi on 3 plus a half cos of 0 minus cos of 0. That's going to be minus 1. That's going to be plus a half. Cos of pi on 3 is going to be a half. So that adds to 1, and that's minus 1, so they add to 0. So where is 2 pi on 3? 2 pi on 3 is in the second quadrant, all stations to Collingwood. Cos will be negative, so the cos of 2 pi on 3 equals negative cos of pi on 3, which is equal to negative a half. So I've got negative a half times negative a half, which is 1/4. Therefore, the area of the smallest region is 1/4 square unit.